Okay, everyone. So we're looking today at water pollution and different ways of assessing the water quality in lakes or any water source, actually. So we're going to start off with looking at different types of water pollution sources. So one source of what's classified as pollution of water is actually acid rain. Okay, so normally we say acid rain, but really it's acid precipitation. You can still have precipitation in the form of sleet or snow or hail that still has the acidic properties. So what happens here is, obviously in grade 10, you'll learn about this a little bit more in depth, but liquids have a property known as pH. Okay, so the pH of a liquid really tells us if we have an acid, a base, or a neutral component. So pure water should actually be a pH of 7. Okay, so that's what's classified as being neutral. Anytime you go below 7, okay, so anything that is below 7 is considered to be acidic. So how does this water that should be 7, how does it become acidic? So the main pollutants is actually from the air, that once it goes up into the upper atmosphere where water is condensing down into the clouds, it actually will essentially be part of that water vapor once it's up in the atmosphere. So the two main components are sulfur dioxide. So it's one sulfur atom and 2 oxygens. So the di means 2. So if you ever see SO2, that's sulfur dioxide. And nitrogen oxides. So actually any compound that has nitrogen and oxygen in it. So this can be nitrogen with 1 oxygen, it can be nitrogen with 2 oxygens, or nitrogen with 3 oxygens. But it's the combination of nitrogen and oxygen in that molecule that will actually cause the rain or the water itself to become acidic. Now, where are these pollutants coming from? For the most part, they're coming from the burning of fossil fuels. So think of car exhaust or anything that uses gasoline. So it could be a train, it could be a car, it could be a bus, an airplane. Anything that is using fuel to burn is allowing that exhaust to go up into the air, which includes these 2 compounds. Or types of compounds, I should say. So burning of fossil fuels is the #1 source. There are some other sources of this, but it's not as heavy of an influence in terms of adding it to the air as burning fossil fuels would. So what happens is, of course, up in the atmosphere where water will condense down with these compounds, when it comes back down to Earth through the water cycle, it comes down now in the form of acid rain. Okay, so acids obviously can be very dangerous. So you're probably wondering, well, when you go outside, if it's raining or snowing, it's not like it's going to melt off our skin or anything, right? So there's different levels of strengths of acids. So acid rain, currently, I should say, is not strong enough to harm living tissue. So for example, it's not strong enough to harm a human being or let's say, a larger mammal, let's say like a whale or a dolphin. However, it is starting to affect different things that are living in aquatic environments that are on the smaller scale. So smaller fish, bacteria, different types of plants. You are going to see, and as this becomes more and more acidic, of course, we're going to see more and more of a change happen. So what are some of the effects? So as mentioned, right, the acid rain will, of course, make their way into the waterways, but it also changes the pH of the soil. So what ends up happening is the soil actually becomes acidic as well. So how does that impact plant growth or the bacteria in the soil? So typically acidic soil has less nutrients than a neutral soil would with like non-acidic water. So what happens is the acid rain or the acid precipitation basically takes away the nutrients from the soil. So what ends up happening is the plants are not able to grow as well as they normally would have. in terms of things that humans have noticed in terms of like everyday life walking down the street, acid rain actually causes iron to rust at a faster rate. Okay, so iron is a metal, and it's found in quite a bit of things. So for example, cars, different sorts of metal, let's say fences. I'm sure you've seen metal, iron in something. Probably cars is the most common thing. So if you've ever seen a car that's rusting, it's because the iron that's in the car, like the actual metal portion of the car, when it's exposed to oxygen, it rusts. Okay, so it turns like maybe an orangey color. Now, this happens naturally. Okay, iron will naturally rust over time because when it's exposed to oxygen, that's when you're going to see the rusting happen. But what's causing it to go faster is the fact that there is acid precipitation. So this process will happen always, but it's going faster now because of the acidity in the water. Okay, over time, it can also cause damage to buildings and statues. Most importantly, the type of material that acid rain will impact the most is marble. Okay, so we don't see a ton of marble maybe in Richmond Hill or even in Southern Ontario, but places like Europe or Asia or in the Middle East where they have a lot of buildings and statues that are made of that material, pardon me, they're starting to find that there is damage to them over time. So again, this doesn't happen after it rains once. We're talking about damage over the long term. So how can we reduce acid precipitation? So the main thing that we can do is we have to use less fossil fuels. So less gasoline, less coal, less oil. Okay, so we have to reduce the amount of sulfur dioxide and nitrogen oxides that are entering into the atmosphere. So we can do that in many ways in real life, right? We can, when it's better weather, we can ride our bike to school. When we can take the bus, right? We can take the public transportation instead of everyone driving in their car by themselves. We can carpool or take a bus, maybe not carpool now during COVID protocols, but when it's safe to do so, of course. Obviously, I know that, electric vehicles are very expensive right now, but that would be amazing to not have any gasoline being used. And I think eventually over time, more and more people will move into that direction. Okay, so let's talk about another type of water pollution, which is an oil spill. Okay, so I'm sure you've heard of this before, or you've seen commercials for, I think it's Downy, is the soap that they use to show that it removes oil from living things like ducks and different fish and stuff. But essentially, an oil spill causes a lot of damage. Okay, so not only damage to, of course, the things that the oil spills onto, so the living things, the seabirds and the seals and the aquatic plants and everything that it actually goes on to, but it also will impact things that will eat oil. So for example, let's say there is a smaller fish that has oil on it. If a larger fish eats that oil, the oil is now going to enter into their system, and oil is a toxic substance to all living things. It's also very slow to break down. It barely decomposes, and it's very difficult to clean up because oil and water don't mix. So what ends up happening is, let's say here's my little lake, right? So the oil actually sits on top. We use black to represent it, but it actually will sit on top of the water. And what happens then is over time, it can block the sunlight. Maybe here's my sun. It can block the sunlight from going into the water. So what ends up happening is the living things that were underneath the water surface will die because what ends up happening is photosynthesis cannot occur. So your producers are not producing and they are not growing. So then our second trophic level will be impacted, and our third trophic level, etc., etc. So this oil, not only is it toxic, not only can it harm the things that it's actually spilled onto, but over time, if it is not cleaned up, it can impact the entire ecosystem of the living things within that aquatic area. So it's very, very dramatically dangerous. So we're going to talk about the different methods that they can use to help clean up an oil spill. So there are 4 kind of main ones. Now, I will tell you that it is very rare that they are used by themselves. Usually they use them in a combination. Okay, so we'll talk about each one of these here. Okay, so the first one is skimming or vacuuming. So as I mentioned, the oil floats on top of the water. So what ends up happening, one method is actually to literally vacuum up or suck up the oil that is floating up on the top of the oil. Okay, into some sort of container. So like a big container where we can put the oil in. Okay, so there's advantages and disadvantages to kind of every method here. So one advantage to this is that it's actually relatively fast to do. So it's not a slow process, it's pretty quick. The downside here is first of all, we may not get all of the oil, right? We'll probably have some oil maybe floating around left behind. But when you vacuum up the oil, you might be vacuuming up other living things as well. So maybe there's, fish or aquatic plants. Like you're basically sucking up everything that is in that oil that is on the top of the surface. Okay, number 2, bioremediation. So this is actually where there are some microorganisms or bacteria that are capable of eating hydrocarbons, which is essentially what oil is made up of. So what they can do is they can actually add the bacteria into the body of water where the oil spill has happened. And then, of course, over time, the microorganisms will essentially eat the oil that's there. Now, of course, one advantage of this is it's something that's very natural, so you're not disrupting the ecosystem any further. But a downside to this is, of course, this would take a very, very long time. So even if you were to add a lot of bacteria into the water, bacteria are very small and it would take a long time for them to actually ingest all of that oil. But as you can kind of see, if you combine the skimming or vacuuming, and then for the little oil that is left behind, you can then add in some bacteria. So it can make sure that any droplets of oil that was left over will eventually get diminished. Okay, number 3 is burning the oil. So oil is not only toxic, but it's also flammable. So one way to get rid of the oil very quickly is to actually burn it. Okay, so the advantage of this is it is very fast to do and it's very cheap. You just essentially have to kind of throw a match over. But in terms of environmentally sound, this is the worst method because, of course, you are creating a lot of exhaust and fumes from this burning of fossil fuels that are going directly into the atmosphere. And not only that, you will also be burning whatever components are remaining in the oil. So again, disrupting living things that may be in that water, that body of water. Okay, so very fast, very cheap to do, but in terms of environmentally safe or environmentally concerned, not really. Okay, and the last type of oil spill recovery here is using a dispersal agent. So this is similar. A dispersal agent is essentially the same components that are found in soap. So if you've ever gotten oil on your hands and you try washing your hands without soap, you're going to notice that the oil stays on your hand because oil and water don't mix. But if you use soap or detergent, you can wash away the oil from your hands. So this is a similar kind of idea. So by adding a detergent into the oil, what happens is the oil is able to disperse and spread out and essentially will not stay at the surface, but it will move into different areas of the bodies of water. So of course, one advantage is you're not going to be creating any fossil fuel exhaust. But let's continue this in the next part.